accumulation problem dealing with the first fundamental theorem of calculus, among other stuff kind of today. I do want to preface today's stuff in saying that like I'm going to be just doing one word problem pretty much for the entire period. Guaranteed, promise you there will be a question that is a free response question on your AP exam. Promise you it's going to be either question 1 or question 2 that will follow this topic pretty much exactly. I can't really ever predict, that sign's been fun all day. I can't really ever predict like what type of situation they're going to use. The AP exam, they purposely choose usually some pretty crazy situations that will model with like both integrals and derivatives. Like I think some of the ones over the past few years have been like fish swimming into and out of a lake. They did one that dealt with snow melting, which actually is a pretty common one. For people getting in line and out of line at like an amusement park, to like anything where there's like something like input and then something as like an output. A lot of this will connect to the first fundamental theorem of calculus, but again, it will also connect to pretty much everything else we've done in calculus. It is going to be word problem heavy. Not really going to touch the calculators today, but typically a problem like this would be on the calculator required section, as in you would not be able to do it without a calculator. So I did want to go ahead and pull up this slide, which is similar to the slide we took notes on Friday, with just a few changes. So the first thing is like we have this thing called the first fundamental theorem of calculus. And we know in general, like I'm going to skip the middle step, we know we find the antiderivative and then plug in the top minus plugging in the bottom. So if I'm integrating from a to b of f of x, I know it's going to be whatever the antiderivative plugging in b minus the antiderivative plugging in a. And that works when f of x is continuous and all that. That's what we already know. And now we're going to kind of start pulling in some of the word problems. One way we're going to think about it is if we integrate the derivative, we're going to end up with the original function. Well, if I have the original function, we'll plug in again the top number minus plugging in the bottom number. And then what was new on Friday was how we could kind of rearrange the first FTC. So like if I added the f of a to the other side, we would end up with this new equation where f of b is equal to f of a plus the integral from a to b of f prime of x dx. And that last one is going to be probably the most important one that we'll kind of notice. Big things you want to kind of see from this. Let me do the green. F of a is kind of like your starting value, and that's where the integral is going to start at. F of b might be what you're trying to find, and that's going to be what is on the top part of your integral. So that is like the math notation of the first FTC. To put it into words, looking at that second row, I have the integral from a to b of f prime. We know f prime is the derivative, and in its most basic form, a derivative represents a rate of change. So I'm going to expand the way we write that formula. Instead of just calling it the derivative, I'm just going to say, instead of, again, f prime of x, I'm just going to call it a rate of change. And we can see in this one, when I integrated f prime of x, it gave me the original function, and it's kind of like the change in the y values of the original function. So we're going to describe the integral from a to b of rate of change as the net amount from a to b. So again, we know that the integral of a rate is going to give us an amount, and I'm going to use that phrase net amount in that case, in case it's like above and below the x-axis. I can rearrange it as well, and another way to rearrange it, this is going to be like the rearranged first FTC in words. So instead of saying f of b is equal to, I'm going to say that's going to be the n value is equal to. F of a is like the initial condition. I'm going to call it the start value. Plus, well, we have the integral from a to b of f prime, which we just said was the net amount. So big idea in how we're going to kind of use calculus is that we can turn, like, when we say the derivative, now we can kind of replace the derivative with just like a rate of change, no matter what we're talking about. Maybe the rate of rainfall, the rate of fish swimming in a lake, the rate of people getting in line, the rate of anything, and we can kind of use calculus to kind of arrange those problems. So to kind of see these problems in context, I took one word problem. This is based off of an AP question. Typically an AP question will just have 4 parts to it, an A, B, C, and D. So I kind of use multiple AP questions to just try to get like all the possible types of questions they could ask you. So everything we do today is going to deal with this example. So I do want to make sure we kind of understand the example, and then we look at, I think there's like 9 questions I have relating to it. So we have the example, we have a capsized tanker is leaking oil into a lake. All right, so then we kind of see they're always going to give you like some functions. They'll talk about the units of that function. They'll talk about maybe when that function is starting, like is it starting when t is equal to 0, or is it starting a little bit later? And we'll have to kind of make sense of that and put all of it in terms of like math notation and calculus notation. So this first function we have is L of t. And L of t is representing a rate. It's in gallons per hour at which oil is leaking into the lake. So there's kind of like the key points I'm choosing from there. Do want to kind of talk about that. I will always focus on the units. Often these questions on the AP exam will ask you to include units in your answers. You always want to pay attention to your units. The units are also useful because you can use your knowledge of calculus to figure out like what to do. For example, if we have a rate, I know the integral of a rate is going to give me an amount. So it can kind of help you set up the problem correctly as in terms of like, do I need to integrate, do I need to take the derivative, or can I use the function as given? And so that's leaking oil into the lake. It gives us this initial condition. It says 4,000 gallons have already spilled in the lake at 5 a.m., which is t is equal to 5. So there's an initial condition. And then it gives me a secondary function. Cleanup is beginning. So cleanup is beginning at t is equal to 5. It's telling us that C of t is that cleanup function. It is representing a rate in gallons per hour. So we have 2 functions here. Do want to be very clear on the problem I based this off of and how it was also on the AP exam. They would actually have functions attached to L of t and C of t. So it might say something like L of t is equal to the natural log of sine of e to the x. Usually it's like some crazy function, but it's on the calculator part, so you can just like use your calculator to do all the work. I stripped the numbers out of this one. I mean, I guess there are numbers, but I stripped the actual equations from this one just so we can focus on the notation today, and then we'll come back and do an example tomorrow that has like actual values and like using the calculator. But today I am going to kind of focus on the notation. Some things I also want to point out on this one and how we want to kind of think about it is both L and C, those functions are representing rates. So when I think about these in my head, even though those aren't called like some letter prime, they're not called L prime, they are in many ways representing a derivative already. They are representing a rate, and we know that we can associate rates with derivatives. So that's going to help us in terms of interpreting it. So we're going to answer the following, again, just using math notation. So we're going to be very picky with like showing integrals clearly, showing the numbers on the integral clearly, making sure like dt shows up, and all that. Again, there is no function given to us, so we won't calculate the number exactly, but we'll talk about like how we would in case we needed to. So looking at this first one, it tells us to write an expression, which may or may not include integrals, to represent the amount of oil that leaks into the lake from 6 a.m. to 11 a.m. So if you're thinking about this one, I think this one is pretty straightforward, but let's just kind of talk about it a little bit. It does tell us that we want to write something to represent the amount of oil. And that's going to be the key thing that you want to focus on. We also are doing the amount that leaks, so kind of ignoring the cleanup right now, just the amount that has leaked in it. And this is where units can kind of be important to us. So if I want to do something that represents an amount, in the context of this problem, what would be the units of your answer to something representing the amount that's leaked into the problem? Gallons. So we know that the amount would just be gallons. The problem gave me a function that was in terms of gallons per hour. So if you have something that is gallons per hour and you want it to be gallons, are you going to take the derivative or are you going to integrate? We're going to integrate. We know that the integral of a rate is going to give us an amount. That's a big thing to know because it will kind of lead you in the correct track of what you want to do. We know we want to somehow show an integral sign in this problem. Well, which function am I integrating? We want to talk about how much has leaked into the lake, so I'm going to integrate L of t. Don't forget the dt at the end of that. And if I want to show how much has leaked into the lake from 6 a.m. to 11 a.m., those are basically going to be the numbers on my integral sign. So I would have from 6 to 11, and that would be your answer. Do you want to talk about this a little bit? So like we didn't have to use the initial condition. It didn't ask us for how much oil had leaked in the lake at 11, just how much had leaked in starting at 6, ending at 11. Big idea of kind of where this answer came from. I know that the integral of a rate is going to be equal to a net amount. Again, we don't know what L of t is, but we know basically the integral of L of t would be some antiderivative of L of t. Plug in the 11 minus the 6. If this was on the AP exam, they would give you some function for L of t, and you would actually have to find the amount that actually leaked. Not doing it today, but just want to kind of remind us how to do that. If you have a TI 83 or 84, you're basically hitting math and then option 9. Punch, punch, punch into your calculator. Always round your answer to 3 decimals. So that's like the setup. On a real problem, there would be some function L of t that we could then evaluate. Never doing it by hand. Always just evaluate it in the calculator. We'll do some of those tomorrow where we actually have to evaluate it. Questions on that problem? All right. I'm just going to run through, again, problem after problem. Same situations. We don't have to re-talk about another one. But I have write an expression which may or may not include integrals to represent the rate of change in the amount of oil at 8 a.m. So we know that we're looking for something to represent a rate of change in the amount of oil at 8 a.m. So again, if I'm thinking to myself, if I need something to represent a rate of change in the context of this problem, what would be the units of that answer? Gallons per hour. Well, if I want gallons per hour, this question is already in gallons per hour. Will I need to take the derivative or take the integral? No, I can just use the function as written. So now I just want to find an expression that would represent the rate. Anyone want to take a stab and a guess of an expression that would represent the rate of change of oil overall at 8 a.m.? Go ahead, Anna.
Would it be like L of t minus C of t?
So I agree that would be L of t minus C of t in some ways. So we do have like the amount leaking in and the amount taking out. But if I want to do the amount of oil at 8 a.m. instead of writing L of t and C of t, we want to be specific and just write L of 8 and C of 8. So this would be the answer. Again, it just asks for the expression, and that's an 8. So you would just leave your answer like that. Again, if this was an actual question on the AP exam, you would have those two functions, and you would just like punch it in the calculator, evaluate L of 8 minus C of 8, enter, and then you would have the rate. Some people like having a formula for this. Again, I try to not overcomplicate these and give you too many formulas, but this would represent the rate of change overall because we basically have the rate in minus the rate out, which is going to give you basically the net rate of change. Again, no integral, no derivative. If we had a rate, we wanted our answer to be a rate. Sometimes we're asked to do a little bit more kind of an interpretation. So here's number 3. It says, suppose we know the amount of oil in the lake is decreasing at noon. So we know that at noon, which will be t is equal to 12 in this problem, the amount of oil is decreasing. We want to write an equation or inequality, so we better see an equal sign or an inequality sign in the problem, to describe what we know about the relationship between L of t and C of t in this moment. I know at least 2 answers you could do for this one that would be kind of correct. Let's connect some things that we know about calculus in general for this problem. Ignore this problem right now. In calculus, what would it mean for something to be decreasing normally? How would you tell a function, I'll say it that way, is decreasing? Negative slope. Slope we know is the same thing as a derivative. So like the calculus idea from this one is that if something is decreasing, so if the amount is decreasing, we would know that its derivative would have to be less than 0. In the context of these problems, we're going to think of the derivative as basically a rate must be less than 0. Well, what is the rate of change of the amount? We already said L and C are already the rates. Those are already representing derivatives. So if we know that the amount of oil is decreasing at noon, then I know that L of 12 minus C of 12, whatever value that is, would have to be less than 0. Some people might have write that another way. That's kind of how my brain thinks of it. So we still have like the in rate minus the out rate. Other people, and this wouldn't be marked wrong, you might say something like, if the amount of oil is decreasing, then basically the rate the oil is leaking would end up being less than the rate of cleanup. Basically, you're cleaning up faster and it's leaking. So flipping around would also be okay. All those would be equivalent and the same answer. Questions on that one? All right, let's go back and throw in some integrals. I have 4, 5, and 6 on the same page because they are kind of related. Let's look at number 4 first. It says, write an expression, which may or may not include integrals, to represent the amount of oil that has spilled out of the tanker and into the lake by 10 a.m. Comparing that to the first one, it was like how much had leaked between a clear starting time and an ending time. This one is just asking for amount by 10 a.m. We are looking for an amount. Since they did give us rates, we know that some integral has to be involved. Anyone want to take a stab at what that integral might look like, or that expression might look like?
It would be like amount equals initial, which is like 5,000, right?
4,000. Well, yeah, the initial. And then what comes after that?
And then you do like integral of 5 to 10.
To 10, and then which function will be integrating?
LT.
LT. And then don't forget dt at the end of it. That will be your answer, basically coming from the first fundamental theorem of calculus. So we have like the start value plus the integral from where that start value was starting at t equals 5, we had 4,000. And we were trying to find the amount at 10, so that's where we're stopping at, and we're integrating L of t. Always thinks it's good to kind of check your units. So like 4,000 is in terms of gallons. L of t we know is in gallons per hour. dt is in terms of hours. We are adding two things in terms of gallons, so it does work out. Like you can't add things in mixed units. So knowing the units will kind of help you check out your answer. And again, if this was the AP exam, you would have some function for LT and just like punch in your calculator and get some answer. Try number 5 and 6 on your own now. They follow very similar to 4. In fact, almost exactly like it, but with different functions and numbers. So go ahead and try 5 and 6 on that same slide. And then we'll go over it. All right, so let's look at number 5. It says write an expression which may or may not include integrals to represent the amount of oil that has been cleaned from the lake by 10 a.m. So looking at this function, we know that we're going to use the C function for cleaning. It says the cleanup function begins at t is equal to 5. No oil has been cleaned up until that time. So we know the initial condition for the cleaning function is technically 0. Again, many of you probably would have left off that, but I am going to go ahead and put it here just so we can kind of see it. So 0 cleaned up initially, starting at 5 to 10 of C of t dt. Obviously, if you left off that 0 plus, you would still be right. I put it on there just to kind of remind yourself, like maybe the problem bit was changed and said at t is equal to 5, 50 gallons have been cleaned up, so you would want to make sure that initial condition would still be there. And then 6 is going to kind of put these answers together. So write an expression which may or may not include integrals to represent the amount of oil that is in the lake at 10 a.m. So if I'm thinking about the amount of lake at 10 a.m., we have basically the amount that has gone in minus the amount that has been taken out. So we're basically combining our answers from 4 and 5. The amount in we had was 4,000 plus the integral from 5 to 10 of L of t dt. The amount out, 0 plus the integral of 5 to 10 C of t dt. Do you want to talk about how we can simplify that answer? So like, if this was a multiple choice question, which they often have these on a multiple choice one of like what would be the setup, they wouldn't write it as 2 separate integrals because both those integrals have the same start and end values. You can kind of combine like terms, if you will. 4,000 plus minus the 0. So at t equals 5, there's a total of 4,000 gallons in the lake. And then we have from 5 to 10, I have the L of t function minus the C of t function with respect to dt. And again, your units are still going to work out. We know that 4,000 is going to be measured in gallons. L of t minus C of t, that was the net rate we talked about previously. We know that the integral of a rate is going to give you amount. So this would still be measured in gallons. And gallons plus gallons works out fine. Questions on that one? Do want to, before we continue to number 7, I just want to make one comparison of a common mistake I often see in these problems. That was going to compare number 1 with number 4 that we did. So for number 4, we had to use the initial condition. And I do want you to pay attention to the wording. So it was like write an expression to represent the amount of oil that spilled out of the tanker and into the lake by 10 a.m. So we had like the initial condition up until 10 a.m. Comparing that to what we saw in question number 1, where it just said write an expression to represent the amount that leaks from 6 a.m. to 11 a.m. So it had 2 time intervals and no initial conditions. That's like a common mistake I see of when you use the initial condition and when you don't. So between 2 time intervals, no initial condition. Up until a specific amount of time, we did have the initial condition. Last one we have to write a statement for, and I'm going to have you try 8 and 9 on your own. This is a common like part D for these questions, and it says write an equation. So again, we have to have an equal sign in there somewhere. That when solve for x would tell us when the lake would be free of oil. I've never seen a question where you actually had to solve the equations. They usually were involved like computer programs to solve, but you just can't solve them at all. But we do want to kind of take this text and interpret it into a mathematical statement. So I'm looking at this problem. When the lake is free of oil, to me at least, and hopefully to you, if the lake is free of oil, that means that the amount would have to be equal to 0. So I'm going to kind of borrow what we did in example 6. What was the total amount? Well, we started at 4,000 gallons. From 5 to 10, we had some water leaking or oil leaking, minus what was being cleaned up with respect to dt. That's what we had in example 6 But it says we don't know what time we had an amount of 0. So instead of putting a 10 up here, that's where the variable is going to come into play. So I have from 0 to some unknown x, some known t is equal to x. This amount would be equal to 0. There's an equation clearly equal to 0, clearly an amount. If you were to solve this for x, that would be basically the x value where the amount would end up being 0. Another equivalent answer, again, that's probably how I would have written it. That's just kind of how my brain thinks about it. Other students might have said there would be 0 gallons in the lake if the amount that leaks into the lake is equal to the amount that has been cleaned from the lake. So that would also receive full credit. Like you clean up all that's been leaked out, then clearly there's going to be 0 gallons left in the lake. Any questions so far? All right, try the last two on your own. These are also common examples, even though they seem a little bit more straightforward. These are, you're going to be working backwards. So I have two statements kind of written as an integral or just like some expression. So I have the integral from 5 to 8 of L of t dt, and then I also have L of 7 minus C of 7. And I want you to write a short sentence explaining what that mathematical statement means in context. As you're writing it, do you want to be very clear on the AP exam? For these types of problems, you have to be very clear about what they represent. So you have to include units on everything. Like when you say it represents the amount, make sure you say like the amount in whatever the units are. If you have an interval of time or even a single piece of time, make sure you're also very clear the units on that. So like whenever you explain these problems, don't skimp on the explanation. It doesn't have to be long, but make sure you do give like a clear explanation with units on it. So try those two. Again, you're just explaining what that would represent in the context of the problem. And this is actually where we're going to wrap up today's notes at. And when I go over it, I'm going to give you my answer, and then we'll talk about like other answers that would receive full credit, and then answers that would not receive full credit. And so this first one, using appropriate units, interpret the integral from 5 to 8 of L of t in the context of the problem. Again, thinking that we're doing L of t is representing a rate. We know that when we integrate a rate, it's going to give us an amount. If you ever forget that, then just kind of think about the units. L of t is in gallons per hour. dt is in hours. So we know that the integral of that would just be in gallons. That will help you kind of form your answer. The best answer for this one, so that integral represents the amount of oil in gallons that has leaked into the lake from 5 a.m. to 8 a.m. That is the best version of an answer you can come up with. Do you want to talk about what makes it a good answer and what you would want to make sure yours also includes? First, you have to kind of clearly say what it represents. So it is representing the amount of oil that leaks. So as long as you're very clear that it's representing the amount of oil that has leaked. You would also want to very clearly talk about the units. So that amount you would have to clearly say is going to be measured in gallons. You would also have to be very clear about the times. This is going to be the amount that has leaked out from, I'll just leave it in blue, from 5 a.m. to 8 a.m. Things that will get kind of you in a little bit of iffy territory is if you just said from 5 to 8, or if you said like from t is equal to 5 to t is equal to 8, if you're not being clear at what those numbers represent. So you want to make sure you're very clear in the context of the problem what this represents. A common thing that I see on the AP exam that people lose points for is they'll say something like the amount of oil in gallons that leaks from the lake, like something like over 3 hours or something like that. Like yes, from 5 to 8 is 3 hours, but you want to clearly state starting at 5 and ending at 8 a.m. So don't say something like that. Very specific and in the context of the problem. Anyone have any questions of one that they wrote down? Just want to see if it would receive credit or not. All right, and then number 9, using correct units, describe the meaning of L of 7 minus C of 7. This actually kind of relates to one that we already did. We know that both L and C are representing rates, so we want to talk about that rate. So this would be basically the net rate of change of oil in the lake in gallons per hour at 7 a.m. Things you would definitely want to include, you definitely want to mention that it is a rate of change of the oil. You would definitely want to make sure we mention that that rate of change would be measured in gallons per hour. Definitely want to be very clear that this would be at 7 a.m., not t is equal to 7 or just at 7, at 7 a.m. And then what I'm going to prefer, it gets kind of in like a little gray area of if you receive credit or not. This technically is still going to be the net rate of change, and I would just put that on there to be certain. So like when you talk about like the integral, like it's the net change, the rate, just put net there, especially when you start doing problems like with position, velocity, acceleration. Like you must always have to include net, which is like a good habit to just say like net rate of change instead of the rate of change. Questions on those last two? All right, so my plans, again, this topic, like they can come up with some pretty crazy questions for this topic. Like if you're bored one day, just start Googling like AP Calculus BC exam and then type in a year from like the last 2 decades and just look at the first or second question. Like they come up with some crazy types of problems. I chose 3 that I want you to do that are kind of like, I think represent like the types of things that you can encounter on the AP exam. So when it comes to the homework questions, I'm going to talk about the homework and I'll kind of talk about what the rest of the week is going to look like. So homework 4 is the one that is, it's obnoxiously long. Like I know, it's the longest homework assignment I give in all the units. On Friday, I assigned, not part B, but definitely part A. Homework 4 part A, which had like an A1 and A2 and A3. That was just like the first FTC without like a word problem, without context, just like making sure you understand that. If you haven't finished that, like you need to do that first before you do the word problems. Once you finish those, then go ahead and start homework number 4, part B. Those are 3 actual questions from an old AP exam. I tried to use one that gave you a graph, one that gave you a function, and then one that gave you a table. So it kind of represents the 3 types of problems you can encounter. If you want to get ahead, like I think that's going to be enough work for now. So like, I know that's enough work, honestly, but like if you want to get ahead, I did go ahead and post the answer to the quiz last period in case you want to look over your quiz. I know that was probably a rougher quiz for many of you, which honestly it usually is for this unit. If you want to start quiz corrections, you can, but I would like to focus on this homework 4 first. My plans for the rest of the week to kind of show you the calendar, so like I knew this topic would take a while. Tomorrow I'm not going to do any new material, so we're still going to talk about word problems in context. I'm going to do one where we'll actually go back and start using the calculator just to kind of see how the calculator connects to these problems. Thursday, we will go back and do some brand new notes, but many of you could probably figure out the stuff we're doing Thursday without me. We're basically just gonna take all this stuff, and instead of saying like rates, we're just gonna do it like PVA, which we know velocity is just a rate, so it's basically the same stuff with just some like different words to it. The problem that we're doing tomorrow, I just shared it with you, so it will be kind of awkwardly at the bottom of your notes. In fact, it might not be shared with you. I have to double check. I don't think it is actually. But we're gonna do a problem dealing with like people entering and exiting like a haunted house. So again, like College Board will come up with some crazy questions. We just want to make sure that we can understand like how the integral and the derivative relates all these like inputs and outputs. So again, what I want you working on, if I can get there, is just homework number 4. I think that's going to be the best kind of thing to benefit you with this topic. Again, guaranteed 100%, either the first or second free response question on your AP exam will be something like B1, B2, or B3. Promise. Unless they do something crazy with the AP exam like they did last year, but we'll find out if that's going to happen. But pretty much you'll see that in the AP exam. They are a little bit challenging. Some of those problems are difficult. And so like I actually expect people to have questions on it, especially if you start working on it today and then leading into tomorrow. So that's where I'm going to kind of end the live portion of class. It's 2:10, so class ends at 2:28, so you have almost 20 minutes to work on stuff. Again, start homework 4. You'll